Hello, this is Romeo Cat Computers, and today I'm going to be making a full bridge rectifier out of 4 diodes. So this is a 100 subscriber celebratory video, and I've had this full bridge rectifier idea planned for a while. I don't know why I chose this, but I kind of wanted to do something for 100 subscribers, so I thought this might be a good idea. So I have this diagram here just so that I don't line up the diodes wrong, and I already have the diodes twisted here, so I'm going to solder the connections together with my soldering iron just to strengthen it, and I'm going to use these wires to connect so that I can actually attach to this. So the green ones will represent the AC lines, and then the black and red ones will of course represent the plus and minus of the DC side. I will not be adding a capacitor, which would smooth out the signal, because all the full bridge rectifier does is flip the negative side of the AC cycle to positive, so you still kind of have humps going up and down. It's not a smooth DC. So normally people add capacitors, but I'm not going to be doing that. I'm mostly just going to be powering like an LED or something off of it. So anyway, I suppose I should start going. Here's the solder I'm using. Some of you might be yelling at me in the comments that I'm using lead-free, but I don't care because I've used it before, and if you know the technique, you can make pretty good solder joints. I don't have a tripod or anything, so I can't film myself soldering, so I'm just going to skip to that being done. Okay, so I soldered all the diodes and wires together into the configuration, and here's my creation. Now the camera doesn't pick it up very well, but all those are very good solder joints. So lead-free solder can be good in these kinds of cases. But anyway, you can see the top and bottom are the AC lines, and the left is negative DC and the right is positive DC. So now I'm going to put this on a piece of cardboard or something like that so that it's all in one thing. So now that we have the hot glue gun warmed up so that we can glue this to the cardboard, let's cool down the soldering iron. Alright, so here's my progress so far. You see I've got the AC lines here, and here's the negative of the DC. And I thought I was done with the soldering iron, but then the red wire snapped off. You can see here I trimmed a bit, or stripped it again, but it wasn't because of the solder joint, it was just because the way I had it positioned, I had put a lot of stress on the red wire, and so the copper just snapped off. So that's why I put a lot of hot glue around the connections so that everything is very secure. So anyway, I'll come back when I get that resoldered and then finish everything else off. Okay, I'm back. So I've resoldered the red wire and definitely reinforced it. And then I added more hot glue. Then I added some scribblings to show different things. So we have the AC lines here, DC down here, and I've marked plus and minus, which the average person should know. Red is plus and black is minus, because that's usually how it is, but just for reference. And then I put the Romeo Cat Computers 100 subscribers thing, and I put the date just for future reference. And of course I have the lines. So let's go inside and test it. So here I am back again with it all wired up. Now of course I'm not gonna just hook straight 120 volts into that, because these diodes are not rated for 120 volts. They'll probably blow up. And also I don't need that much DC anyway. So I have it hooked up to this transformer, which will step 120 volts down to 12 volts, then hook the 12 volts AC here, and I should get about 12 coming out, ideally. So I haven't plugged it in yet. Now once I plugged it in, I have the negative connected so that I can just go and touch that, and I'll probe it on the multimeter, and the multimeter will tell me how much voltage I'm getting. So, without further ado, 3, 2, 1. Okay, nothing blew up, that's good. So, I guess now we need to measure this. Well, it keeps fluctuating because I'm not making very good contact. And there we go, about 10.4 volts DC. I will mention that this thing doesn't output exactly 12 volts. It outputs more like 11.6. Now, because I didn't put a capacitor here, like I said earlier, all it's going to do is take both the positive and negative cycle of the AC and flip the negative, so it's just two humps going up and down. So there are gaps between those humps where there's nothing, and so you won't get your full potential without getting a smooth out capacitor. So now let's see if we can hook an LED up to this. Okay, here's the LED, and you'll notice I put a resistor. These LEDs are not meant to run on 12 volts. I don't know exactly how much they're meant for, but somewhere between 1.5 and 3. So if I hook it up to 10 volts, it'll probably fry itself. And so the resistor I'm using, I wasn't quite sure, so this is just a 2 kilo ohm resistor. So let's hook it up. And 1, 2, 3, contact. Oh, it's not working. Oh, well, there it just came off. Hey, there we go. My connections are not very strong, but as you can see by the demonstration, of course if I get it just right, it will turn on. But anyway, I think that's going to be it for this video. Thanks for watching, and thanks to everyone who has subscribed, and especially those few people that have been around since the channel first started about 2 years ago. Anyway, I hope to see you in the next video.